So, good afternoon.
Good afternoon, sir.
Am I audible to you?
Yes, sir.
Am I audible? Can you hear me?
Yes, sir.
Yes, sir.
So, good afternoon, everyone. I think I am audible to you. Can you hear me?
Yes, sir.
Yes, sir.
Hmm.
Yes, sir.
Can you hear me? Speak something. Somebody speak something.
Yes, sir.
We can hear you.
So, we are starting. That today we are going to discuss this one. That is the motional EMF due to rotating rod in magnetic field. So, in the last class we have seen the motional EMF equation for motional EMF. It was E equals BLV. This was the equation what we have learned in the last class. E equals BLV. V is a magnetic field, L is a length, and V is the velocity with which the metallic conductor is moving in that. See what happens in the case of a metallic rod if it is rotating like this. Okay, if it is rotating like this, what will be the EMF induced between the ends of the metallic rod if it is moving in a rotational path in a magnetic field, uniform magnetic field. We know that L, the length of the conducting rod, and V, omega is the angular velocity. See this omega is the angular velocity of the rotation of the rod. And of course, T is the time period. Then we can have E is as usual d phi by dt. EMF is d phi by dt, that is d by dt of B dot A. Then VA cos 0 by T. Then A is pi L square. See that where L is the length of rod. Okay, pi
Sir,
L square
presentation
by.
കാണത്തില്ല.
The t we can write it as 2 pi by omega. T is the time period. This we can take it as 2 pi by omega. Then we can write there as half b L square omega. Half b L square omega. We can write like that. So the EMF developed in a metallic rod. See, if a metallic rod length L is rotated in a magnetic field B, then the EMF induced will be equal to half B L square omega. Half B L square omega. So that's the equation. So the current we can take it as current is EMF divided by R. So it is half B L square omega divided by R capital R.
Sir,
The power is I
presentation
square, or we
കാണത്തില്ല.
can take I square.
പ്രസന്റ് ചെയ്യുന്നില്ല.
So heat energy dissipated will be equal to energy, that is power multiplied by time. So heat energy is equal to power multiplied by time. H equals power multiplied by time. That we
സാർ
can write like this. Now let's
കാണുന്നില്ല.
see this problem. A ceiling fan. Each blade has a radius of 0.5 meter. If the fan makes 2 rotations per second and vertical component of Earth's magnetic field is 8 into 10 power minus 4 Tesla. So we have vertical component, that is BV equals 8 into 10 power minus 5 Tesla. Then radius equals 0.5 meters, 2 rotations per second. So omega angular velocity is equal to 2 rotations per second. 2 rotations per second. Now let's see how we are going to solve it. So we know that half B L square omega or half B R square omega, EMF is half B R square omega. Omega is vertical component is already given there, so no need of going for vertical component. Directly we can take the vertical component. Then R is there, omega is also given there, so we can directly substitute these values into this equation, and we will get it as 12.56 into 10 power minus 5. Now you see this problem. Two identical coils, one of copper. First one is of copper, and the other
Sir,
of aluminum, are rotated with the same angular speed in an external magnetic field. In which of the coils will the induced current be more? Induced current be more. Both the coils are identical coil. One is made up of copper and the other one is made up of aluminum. Okay. The difference between copper and aluminum is resistance of copper will be less than resistance of aluminum. Resistance of copper will be less than the resistance of aluminum. And we know that current is equal to EMF divided by R. So these are the 2 points we have to remember while solving this equation. Resistance of copper will be less than resistance of aluminum, and current is equal to EMF divided by R. Let's see the solution. It is copper coil, because the reason is current is inversely proportional to resistance, and resistance of copper is less than resistance of aluminum. So this is the reason for this.
Sir,
Now a circular loop of radius r carrying a current I lies in the YZ plane with its center at the origin. The net magnetic flux through the loop. Net magnetic flux through the loop. We know that flux of I is equal to B dot A.
സാറൊന്നും കാണുന്നില്ല.
That is BA cos theta. BA cos theta. Theta is the angle between area and magnetic field. So it is lying in the YZ plane. YZ plane is like this. This is the YZ plane. Okay. So Y and will be lying like this. So net magnetic flux through the loop. Net magnetic flux through the loop. Now, see this question. Expression for the induced EMF developed when a coil of N turns and each area of cross section A is rotated at a constant angular speed omega in a uniform. These are the typical questions which are expected in the CBSE examination. So this is another model, a wheel with 100 metallic spokes, each 0.5 meter long, rotated with an angular speed of 120 revolutions per minute. So angular velocity omega equals 120 revolutions per minute. So it will be equal to 120 revolutions per minute. It is 120 revolutions. So per second it will be 120 revolutions per minute. So per second we have to divide it with 60 seconds. So it will be 2 rotations per second. 2 rotations per second. And magnetic field is given there. Resultant magnetic field at the place is, that is B equals 4 into 10 power minus 4. Angle of dip is 30 degree. Delta equals 30 degrees. So we have to go for B vertical. Let's see how we are solving it. NBA cos omega t, then d5 by dt, that is NBA omega into minus sin omega t, that is the differential. Then velocity is 2 rotations per second. Then B is 4 into 10 power minus 4, delta is 30 degree. Then B, here we have to take, it is going in the horizontal plane. To the horizontal, see, in a plane normal to the horizontal component of Earth's magnetic field. So it is moving in a plane normal to the horizontal component. So here we have to take the horizontal component of Earth's field, since it is moving in horizontal plane. So here it is written as 120 revolutions per minute, number of rotations per minute, that is frequency is given. Frequency equals 120 rotations per minute. That is equal to 120 by 60 rotations per second equals 2 rotations per second. So this will be the frequency, not the angular frequency, it is the frequency. And we know that omega equals 2 pi f. So f is given there, 2 rotations per second, that is the frequency. Then omega we can calculate 2 pi f, so it will be 4 pi radians per second. So we can substitute all the values here and we get the answer as 5.4 into 10 power minus 4 volt.
Sir, sir,
In relation between induced charge and change in magnetic flux. Faraday's law, it is like this. So the relation is delta phi equals delta Q divided by R. This you have to remember. Delta phi, change in flux, equals change in charge divided by resistance. Charge by resistance equals change in flux. This you have to remember. Now the eddy currents. Eddy currents, we know it is the currents induced in a conductor, not in a coil. It is current induced in a conductor when the magnetic environment of the conductor is varying. So it looked like eddies. It looked like eddies or whirlpools in water. That's why it is called eddy current. So eddy current, basic nature of eddy current is it forms continuous loops here. You can see this current. It forms continuous loops. So if we are able to break the loop, if we are able to break the passage of this loop, then we can stop the eddy current. Okay. So remember, eddy currents are the currents produced in a conductor where the magnetic environment of the conductor is varying. See, these are the demonstrations related to eddy current. It is actually undesirable in some cases, and in some cases it is desirable. And in the case we have studied the transformers. In the case of transformers, the core of transformer is made up of metal, and in that metal eddy current will be formed, eddy current will be looping, and the core will be getting heated. In such cases it is undesirable, whereas in certain other cases it is desirable. So eddy currents, uh, wherever this heating is there, the heating produces wastage of power. Okay. Here a magnet is being dropped through a metallic surface. So when the magnet is falling down, the magnetic field associated with the copper plate is being varied, and an eddy current is developed in a copper plate. And because of that eddy current, there will be magnetic field in the copper plate, and it is getting slowed down. This is getting slowed down. How can we minimize the eddy current? Can we minimize it by using laminated core in metal sheets? Okay, we can cut it into metal sheets, and the shape can be modified like this. Otherwise, what happens if this is moving through this? If it is moving back and forth, okay, now if it is moving back and forth, eddy currents will be looping in this metal sheet, and large amount of heat will be wasted in the form of heat. Sorry, large amount of energy will be wasted in the form of heat. And if we make cuts like this, there is no space for the eddy current to loop, and formation of eddy current will be lesser in this case. And of course, we can reduce the surface area. Surface area can be reduced, so eddy current will be getting reduced. And laminating the core. The core can be laminated, means coating it with plastic. See, in both cases, one is not having any cut or anything. This is one is not having any cut or anything. The second one, which is having cut, so less eddy current will be induced, less it will be magnetized.
സാറിന് ഞങ്ങൾ പറയണ എല്ലാം കേൾക്കാവോ? ഹലോ സാർ, ഇൻട്രസ്റ്റിംഗ് സാർ.
So this is a
Sir.
hollow cylinder. You see this case. When you drop a magnet through the hollow copper pipe, see what happens. It is getting, copper is getting magnetized, and it opposes the movement of the magnet through it. So remember, whatever be the induced current, the nature of the induced current will always be to oppose the original cause, producing the induction. It's a top view. Okay, see this one. These are same thing.
സാർ ഇതൊന്നും കാണുന്നില്ല സാർ.
So when the magnet is falling, there will be change in magnetic flux associated with the cylinder, and eddy current will be formed. Then these are the applications of eddy current. Just you must remember the names at least. Another application is this metal detector. So this is how a metal detector working principle of a metal detector. So very low frequency metal detector. So if a metal is there, see this one, metal is there, a coil will be there, okay. So
Sir,
there will
അതൊന്നും
be
കാണും.
eddy currents formed on this metal. Eddy current will be looping, and this will develop a magnetic field, and the transmitting coil will detect that magnetic field produced by this metal surface. So the buzzer will make a sound. The principle there is, it is the principle of electromagnetic induction. So one or more inductor coils will be there, interact with metallic elements. So metallic elements will have eddy currents looping inside that. So this will have a magnetic interaction with the magnetic field produced in that metal surface. Hello. Okay.